for your future careers, and hope I'll make this session very interactive one. And without much this thing, I'll go to the next first slide. So production technology, we call production technology today, it is art of making things. Art of making things is about human race, which has evolved, from the Stone Age, where he found lot of tools he developed over a period of time, starting from fire to wheel and the stone tools. And there were different ages like Bronze Age, Copper Age, and Iron Age, like that. So today we are in a very advanced age. Are you able to hear me, Saif? Can
Yes.
I get a feedback? Am I audible?
Yes, sir. You're audible, but we can't see your screen. Could you stop the share and try again, sir?
Oh, I see. You are sharing screen.
Yeah, just stop the share and try again. Yeah.
Okay. I'll share again. Can you see? Can you see it? I think you may have to pin
Yes,
it
sir.
or something.
It's visible now. Yes, sir.
There's also all of them are seeing it. Just check it.
Even the panelists are seeing it. Yes, sir.
All are seeing. Okay.
Even the utilities.
So we are discussing about art of making things. Okay. Oh, I'm unable to move forward. I'm unable to move forward in this.
Yeah, just click on the presentation one more time.
Okay. Okay. We're just moving here. Okay. So can you see that the second screen now? Okay. In art of making things, people have been doing everything by hand. It was all craft, And as we move on, the handcrafted, the cottage industry, like our grandmother used to weave and do sweaters for us, those kinds of things came. Even today, a lot of things are being done by hand, like making baskets, etc. And all of them, one cannot make 1,000 numbers. Few samples only they can make and sell. So the industrial revolution is a period when people wanted a lot of things to be made and sold and consumed. That led to a different type of order, different types of technologies. Man had to develop machines, in order to do that. And we all know for a long time, what you see here, the pottery was one of the early things, artifacts made, and this was made in different ways. It was made like on a lathe, you put a thing and use a cutting single point tool to shape it. On a potter's wheel, one shape it even today, right? And we also have another way of making things. This is called pinching. You take a clay and you start pinching it, and it expands, and you get the entire pottery made. That is a vessel to contain something. It can be water. It could be.
I'm so sorry to interrupt you again,
Yeah.
but I think the screen share has stopped again. On your share screen, do you see an option to share with attendees as well? We're getting complaints that it's not visible.
No, I think the attendees have to pin it. So I'll share it now. Attendees, I think, have to pin it. So desktop, I'll say share. Okay. Can you see now? Can you see now?
Hold on, let me just ask the attendees. Okay, so the screen is visible now. Yes, sir.
Visible. Okay. Okay, fine. Is it moving now? So I have a problem here. Okay. When I go in this mode, I am not able to myself see the screen. I'm not able to advance it myself. See, it is not advancing. Okay, now let me see. Okay, it's advancing now. Okay, okay, fine. Can you see this now? Is it advancing?
Yeah, yeah, it's advancing, sir.
Okay, I'm sorry about this. Sorry, all of you. So we were here. So there were different ways of making the same pot. This is by pinching, and there is another way of making things like make a ring and smudge them together in order to make the entire vessel. There were different. Even today, you can see this type of technology being used to store water and all, especially in summer. You have it. In fact, early days, everything was carved by hand, just like this, what they're seeing. This is a Renaissance chair. You know, See the ornamentation here, so beautiful. They depicted the nature, and nature is the best designer. So people used to have a liking for the nature's flowers, animals, and they used to make them part of their lives. It used to reflect everywhere in their ornaments, in the house, the furniture, the utensils, whatever it used to have like that. And same thing you can see till recently, a machinery also used to be looking like a very ornamental thing, like a piece of jewelry. What you see here is a sewing machine of the early days. And then came the so-called different industrial revolutions which changed all this. Let us see. The production technologies can be divided into three main broad categories called plus, minus, and zero processes. Let us understand what are they. The manufacturing process broadly is classified into plus additive manufacturing processes, zero or forming processes, minus subtractive processes, in which you have so many things. Under plus, you have casting, welding, cladding, painting, plating, gluing, lamination, coating, and of course 3D printing. And under zero process, you have bending, extrusion, drawing, forming, forging, coining, rolling, knurling, embossing, all these processes. Under minus, you have turning, shaping, milling, drilling, lining, broaching, trepanning, sewing. Then you have reaming, grinding, filing, chipping, all of them. This is like a sculpting. And this whole thing, led to the conventional manufacturing, which we normally call it as subtractive, where you can see we remove chips out of metal and shape it, like a milling, where we again remove. All these lead to a lot of chip generation. You know, so this was not at all very good, to generate so much of waste and remove a lot of material. So people thought this is a kind of a process which is not good, and there were a lot of other ways of making things. Can we add material and make? So casting was one of them, which was developed, where you get the shape directly. The Industrial Revolution 1 brought in a lot of energy into human hands. So human hands were not shaping anything now. The machines were there. They were able to make a lot of things in a short time. Then came the Industrial Revolution 2, which brought in the production line. The chassis enters in one side of the factory and goes out as a car with four wheels. And the whole line is called as production line. This was implemented at Ford's factory. What you're seeing is early Ford factory. It was looking like this. A lot of people doing just some job, and it is to move forward. And you know, this industrial revolution brought in a lot of limitation into so-called production system. The ornamentation uh, went off. In the world, we could only make horizontal and vertical things, or at best something round, something triangular, things like that. And this became a new aesthetics to the world. We started calling it as a minimalistic approach. Today, we have Apple, which is a great icon of minimalistic approach of design. And very much like our houses, which are boxes today, we find everything which is a box. And we say creativity is out of the box. And because all this came as a limitation of the process, the machining brought in all these limitations, and the limitation became a new order. And people said, okay, it is like, um, uh, the jackal says, if I cannot get grapes, I think grapes are sour. I don't like that. So we got used to this kind of new aesthetics, which is minimalistic, made up of horizontals and verticals. And today, I think with the new technology, new way of making things, we can go back to Renaissance. That is the beauty of it. We can enjoy the old way of making things and just one off. Okay. And that is the beauty of new technology, which we are going to discuss today. And you can see with the new technology, a lot of things changed. The sewing machine, which you saw some time back, was so ornamental. Today we find it reduced to lines, horizontal lines and vertical lines. It looks very much like a machine. It is a machine, okay, but the ornamentation is gone because of the limitation of the process. And then came Industrial Revolution 3, which brought in the power of computer. And computing power, though what are seeing on the screen is the first electromechanical calculator, which was huge, like a big room. It brought in a lot of things like automation, robotics, and we call this as even technology, telecommunication technology also got implemented. The valves to transistors to IC, that development also came in the third industrial revolution. And today we are stepping into the fourth industrial revolution, where for having crossed first, second, and third, we are in a fourth industrial revolution. We are stepping into fourth industrial revolution, wherein we are going to have autonomous robots doing everything, and very less intervention of humans are required here, and we call it as cyber physical system. Moving forward, today's topic, the 3D printing, we call it as the next big thing. For last 30 years, it has been a next big thing. This is because it has to actually create value. Unless 3D printing creates value, industry and people will not adopt it. Okay. But today, I can say it has actually arrived. People have got technologies by which you can actually manufacture. Additive manufacturing, sometimes I don't call it as additive manufacturing because manufacturing is a highly loaded term. What is manufacturing after all? It is making millions, not making one or two or making hundreds. So additive manufacturing, I sometimes call it as digital fabrication. Moving forward, we have this in 3D printing. We have the first term called printing. What is printing, by the way? Printing is a process of reproducing text and images. Okay, and in case of 3D printing, it is a process of 3D printing means 3D printing not only text and images, but also objects. That's where we call it as 3D printing. Sometimes people come, I want something 3D printing to be done. They'll give a small 2D artwork. Many times they think that it is going to be printed in 3D. So a 2D plane looks like a 3D. So it is not so. Many people have a misconception. So printing and 3D printing are way apart. They're not the same. Only I can say in the world we have only printing, 2D printing. 3D printing is something which is a integration of 2D printing done over and over again. Well, uh, many times we call 3D printing also as additive manufacturing, as you know. And when you say additive, there are a lot of things which are additive in the world. Plywood is also made up of additive, but it is not 3D printed. Bricks are, buildings are built of bricks like a Lego. And again, it is not 3D printing, but it is additive. For example, casting is also additive, but it is not 3D printing. So if you do joining of metals like welding is also additive, but it is not 3D printing. So there are a lot of things which are additive, and 3D printing is a subset of additive. So 3D printing is a new way of making things, and many people think that 3D printing means it is made up of filaments. So it is like blind man, a set of blind man going and touching the elephant, and whatever they touched, they felt so, and they declared this is what it is. Elephant is like a fan. Elephant is like a tube. Elephant is like a pillar, like that. So today, the term 3D printing is like that elephant. Some people say it is SLA, stereolithographic apparatus. Some say it is SLS, selective laser sintering. Some people say it is FDM, filament position modeling. Some people think it's a loam, laminated object manufacturing, binder jetting, material jetting, and all that. So this diagram really says 3D printing is just not one; it is many. So these are some of the pioneers who actually brought in all these different concepts, starting from Dr. Kodama. You have Chuck Hull, you have Coil Decoy, Stephen Scott Kerr, and many others you can see here. Emmanuel Serge from MIT, he coined the word 3D printing. At one point, 3D printing was actually a trademark of MIT. But soon he gave up the rights. The whole world today calls this process as 3D printing, and thanks to Emmanuel Serge from MIT. He's a professor who actually created what we today call it as binder jetting. Well, coming to the inventor who got the patent, Chuck Hull from America 34 years ago. Maybe now it is more than 34 years ago. And he called it as an apparatus. He called the process as stereolithography. So beautiful, the term. Stereo means what? Stereo means depth. And lithography means printing. So the 3D printing or depth printing is what he said. And you can see his operators, how it looks. The one in the middle here is the apparatus he made. And even today, we call this process SLA, and A stands for apparatus, stereo lithography apparatus. The first part he made. Well, moving on, we can have the definition of a 3D printing now, as 3D printing refers to a set of technologies which help to fabricate 3D object layer upon layer with the help of a digital input data. The digital input data can be from a computer model, or from medical image slice data, or from the cloud, point cloud out of a scan. If you have an object, you can scan it and you get a cloud of points. And those cloud of points, you can use it to make a model. That's all. So these are all inputs to do a 3D printing. So if you see the block here, 3D printed thing, first thing is 3D CAD model. Without a 3D CAD model, you can do no printing. Printer needs this very important input. Further, it also has to be sliced using a software. And then there is a generation of code called G code that is given to the machine. What machine does, after the object is sliced, the digital model is sliced, it is going to put back the slices in a sequence, layer upon layer. And what you get is the actual object. So it is like dematerialize and materialize later on. So I think people used to call 3D printing as a 3D fax also. That is one of the term given to 3D printing. Excellent, isn't it? Moving forward, Dr. Adrian brought the concept of 3D printer printing itself. So much so is a cartoon, which is there. A 3D printer is giving birth to smaller 3D printers and like that. So he brought in the so-called open source regime. Anybody can think of it and do it. In fact, it is after this, the maker movement brought in different kinds of FDM. These are all the allotropic forms of FDM, the filament deposition modeling, what we call FDM. This is called Cartesian, Delta, Polar, and Scalar. All of them are result of the, barring the first one, these are all result of the open source innovation. And in fact, it has made the whole spectrum very rich now. So if you look at the traditional process and additive manufacturing or 3D printing, you see additive manufacturing uses less energy, and also it since it adds material instead of removal, the scrap generation is very minimal. So we call it as a green manufacturing process also. So it is a act of converting CAD to part directly. And moving forward, many times 3D printer is not supposed to be just a box. So this is questioning the stereotype or biases what we have, mindset we have for a 3D printer. What you see here is a KUKA robot, which is getting digital data from a CAD system, which is able to create an object. So it can create an object here, here, and all around it. It's truly out of the box 3D printer, I can say. So by definition, even this is a 3D printer. Let us see, this is a 3D doodler. 3D doodler is something like FDM. The filament goes in and it comes out in the hot nozzle here, what you see, and you can create a lot of 3D objects. Is it a 3D printer? By definition, no. Why it is not a 3D printer? It looks like a 3D printer, works like a 3D printer, but it is not a 3D printer. Why is that? That is because there is no digital input data here. Your hands are controlling it. And from the mind, whatever you think, you're able to make it like a mehendi gun, or a glue gun. Beyond that, because it is not having a digital data input to this, it is not a 3D printer. So what happens if I put this in the hands of a robot, or I'll make that XY table is going to move this, or XYZ is going to move it. Is it a 3D printer then? Of course, yes. Then it becomes a 3D printer. So that's how we have to learn what is 3D printer, what can be classified as a 3D printer. Tomorrow, all of you can come out with your own, but you can go back to the definition, where we had definition, where you had a definition here. 3D printer refers to a set of technologies which help to fabricate 3D objects, layer upon layer, from digital input data. Full stop. That's how it is. Okay, moving forward quickly now. We're done on this. You see, the beauty of 3D printing is it brings in a lot of complexity that can be done using 3D printing. These were nightmares. Even to think, they're unthinkable objects, what you see on the screen now. They're all actually made up of complex mathematical equations. And if it is f is equal to x of y plus c something, you keep on substituting things. People, they used to get different objects on the screen. They keep morphing. They stop it there and they say, okay, you then export it as a CAD model, STL model, and then you give it to a printer and printer prints. So it is. It can be likened to the toy what we used to use when we were children, called kaleidoscope. Kaleidoscope used to have three mirrors, and you're going to have some chudi, colorful chudis inside, powder or glass beads, and you keep on turning. At every turn, you used to see a new configuration. So this is something like that. What you see on screen is something like that. In fact, in design in future, a lot of mathematicians will be required to design future designs because they are unthinkable, just like what you see here, and they're only capable of being able to be manufactured or made by 3D printers, and that creates a lot of value. In fact, 3D printing brings a lot of good things like assembled product. You know, a lot of complex things can be combined together. We call it as part consolidation. You know, if you have product made up of some 10 parts, we call it a bill of materials. 10 parts are required to make one. Today, we can combine all of them. You know, so there is no need for assembly, and people don't assemble wrongly. So there is a lot of mistake proofing that happens, and reliability of the system increases because you don't have variables, too many variables. So you have just one part, you fire one part and you use it, you know, something like that. So that is the beauty of this process. And you can make those quick jigs and fixtures like the one what you see here. The red part is 3D printed with a PCB, and PCBs are constantly changing. They are becoming miniaturized every day. So how to manage handling them? So you can quickly design a fixture for that, and one can hold here and move it to the next stage. So easy. And moving forward, they're also going to help us make very complex objects like the one what you see here. It's very complex object. And complexity here comes for free. It doesn't ask you any question. It doesn't ask you extra wages for this. You know, that is the beauty. And so much so, 3D printed objects can be used as a master, you know, and we can cut a silicon mold and we can take out multiple pieces out of it. So this is something like 3D printing enabled batch production is also possible, and we call it as vacuum casting. So I'll show you vacuum casting, how it looks. You can see here, this is a vacuum casting. These are all silicon mold. You can see the pieces. Using one mold, you can take out different colored pieces. Every time you inject a different color, you get these parts. And this mold can be made overnight. Yes, just 12 hours, sometimes even less. And further, a 3D printed pattern can be used to cast metal like this. You know, that is also possible. Today, people are able to cast in metal, all types of metal, and titanium, gold, then you have iron, tool steel, copper, aluminum, many of them. In fact, we can also print molds. You know, mold is a means to an end. It is not an end itself. But today, we don't require molds at all. If you can make a product without a mold, why not? But here we try to print a mold. So there's a mold printed at Imaginarium, and this also produces a lot of good outputs. What you see here is a large 3D printed object. Caption here, 3D printing big here. You can see here very characteristic layer by layer, you know, marks here. This is a part of a big castle. People are making it, by parts, and that will be assembled. And they're all 3D printed using concrete clay, you know, concrete mix, ready mix. And what you see, if it is assembled, you can see a castle here. You know, it has got its own limitations, and you can see the Gothic style. You cannot insert a steel frame or beam here. You know, so they have kept the uh, overhang very less here. Triangle can be constructed, and these domes can be constructed. It has its own limitations, but it was done in 2014. This is a demonstration of the capability. So today people have been trying. There are some buildings constructed in Dubai and all, which are totally 3D printed. That's what we hear. And you see this is IIT Kharagpur, main building. And what is it doing here? In fact, this was so big, it runs kilometers in length on either side. The main building, the hall, lobby, what you see, the main building, the fascia. But the same thing was printed. They printed it, you can see here, they printed small. Printing small, they used a printer called nanoscribe, and here you have 20 micrometer, the scale. And if you see one of these small lines here, it will be a few microns only, maybe 1 micron, sub-micron, if this is 20 micron. And you can see that is the capability of 3D printing. You can print big, you can print small also. That is the capability you have. And today, jewelry is a piece of fun. With 3D printing, one can freak out, in design. The thing, what you see here is a piece of plastic, but it is a piece of a joy. People are able to design such things. These are all unthinkable when they were doing early industrial revolution days, or even before. Only people used to hand sculpt it. Today, I can make one, I can make hundreds. Just from CAD, it can be produced. In fact, consumer end printers are small, they look cute, they look like boxes like this. And even these small printers have a enormous capability, like this one. You can see this small printer, it could make all the parts of this mammoth, what you see here, the big elephant, the Ice Age elephant, with all the fur. It was made up of small pieces made on this printer, and like a Lego, they could put them together to have this. So it's like a chuparustam, so small, but its capability is so huge. In fact, in industry, 3D printers, except few 3D printer which are installations, like very large ones, most of the 3D printers, they make small parts that are craftfully joined together in order to make big things. Moving forward, you can see people have now got entire seal system, wherein 3D prints, it does the CNC inside, it does the cleaning, and it is then ejected out. The interaction is through IoT and or an external screen to have a manual override. Otherwise, you don't have to enter and do anything with it. Such a capability people are already providing, and the order of the day in future, all industry will transform into small container looking factories. Such factory can do anything. They can do food, drugs, cloth, and whatnot, anything, in future. So industry of tomorrow, they will look like this. The shop floors will be very neat. They'll be clean. There's no grease and oil. You can see all of them. Or future factory, how they look like. And it's very important to know this technology arrival and matching with the today's emerging customer. Who is the customer? New customer. It is not you and me. It is actually the children who are born today, or the children born some months back, years back, the millennials onwards. They have a different kind of mindset. They got everything on platter, and today we have these, what I can say, uh, millennials. They want everything to satisfy their personal needs. Okay, They want to stand out in the crowd. You know, they want everything to be not only customized but individualized also. And this is made possible because of the capability 3D printing is gaining over the years. What used to have only the capability, early capability was only to make a mock-up model, which is a dumb model, like the cell phone, and to a design validation model, which came much later, which used to be accurate and it used to give feedback about the product and design and how to improve and all. Today, we have end user parts. You know, such is the capability. So today is the right time for the new customer, the emerging customer, who wants everything now. You know, so this is the significance of the new customer who wants to stand out in the crowd, and it takes all kinds to make this beautiful world. And this is a nice cartoon I got on WhatsApp. It says the nature of new customer. Who are we? We are clients. What do we want? We don't know. When do we want it? Now. You know, so such is the urgency of new customers. So in order to serve them, uh, the manufacturing has to be really very agile. Complex geometries on one side and needed in a very small batch quantity. Having a big factory, you cannot deliver it. And that's where we bring in what is known as parametric design. What is a parametric design? It is mathematical model or a geometric model that is redefined by the user. For example, let us take a cylinder like this. Cylinder has got a radius and height. You know, I can change it. You know, I can have a product like this. I can keep changing the dimensions. I get different objects, right? Same way, let us apply to a ring, a simple ring. You know. So you can see on the right side the table. As and when I change the slider, the object changes its dimensions also. And you can see how if I play with frequency, amplitude, how a simple thing change. You can see all complexities I change, I'm going to get a very weird looking ring, and I can still modify it, and I can modify it even to have a simple design. So, you know, the converting design as a kind of a user experience where user feels that he is designing. Such things will come into picture in future. The parametric design is going to enter the world in every aspect, not only just ring, everything. Your drinking water or your car, your furniture, your dress, your spectacles, jewelry, your accessories like belt, then watch, everything can be done this way. So the designs will be curated and people are going to have, you know, enjoy life, and they will feel that I've designed my product. You can see. So design will lead the consumption. Manufacturing would be taken for granted. Who bothers how it is made, you know, after all? And so the whole digital switch will happen in the supply chain management. Supply chain will become demand chain. Somewhere in the world, somebody sitting in the one corner, they will order something on the cloud, and somebody is there ready to make it for them. And he pays online, and you know, you have this transaction done. So this is called demand chain. And today, you know, the 3D printers come in all sizes and shapes. Every technology has its own unique way. You know, what you see here is some of the different systems what we have at Imaginarium, you know. So if you reach Imaginarium, you reach the world of 3D printing. I think I'll extend an invitation to all of you sometime. When you're in Mumbai, please do visit us. We'll be happy to show you around. And the future of 3D printing is moving beyond prototyping to the end user part. You know, the product itself, which you can use for entire life cycle. And This is made possible by some of the technologies such as multi-jet fusion. So this is a product from HP, Hewlett Packard, the printing people, who also make a lot of IT and computer hardware, etc. And they had a lot of patents actually in the early days on 3D printing. They were not 3D printing; they were licensing it to others. Then, as a strategy, they changed their strategy of licensing it. They said, "Why don't we also, do 3D printers?" And that's how they came out with a new technology called multi-jet fusion. What is the beauty of this technology? It gives you speed, it gives you quality, and at a reduced cost. This is a kind of an impossible triangle for manufacturing: getting speed, quality, and at a better cost. And today, in the whole thing, the space of 3D printers, small and medium and large size are there. They'll all be maintained and run by the OEMs, while the small individual designer, maker, artist will go to cloud factory. You know, Cloud factory is people don't have to worry about what printer, how it looks, whom. They have to just upload a file and they get it delivered to their door. Such is the change that has happened. Even Imaginarium has a cloud factory. If you type www.imaginarium.io, you will get a cloud factory, and you can actually get into that. Try that. It will be fun. In fact, 3D printing has one advantage, and it has got a lot of disadvantages. Now, what is the disadvantage? The main disadvantage we have: there is no economy of scale. What is meant by economy of scale? Unlike 3D printing, if you take any large scale production, for example, your water bottle का cap का क्या दाम होता है? It's very, very less. Why it is less? Because they make millions of that. Because they make millions, the landed cost of that becomes very, very less. Whereas in the case of 3D printing, because every part is built layer by layer, it has got the same time to manufacture, same type of material, so you don't get advantage of scale. Okay, so we say there is no economy of scale. So that's one disadvantage we have. But complexity comes for free. Complexity means if you want to make a cylinder or a very complex, floral thing, both will not considered to be complex for a 3D printer. Whereas for a conventional manufacturing, if you make a cylinder, it will cost you less. But same cylinder, if you make it very ornate, then it will cost you more. So more you process it, more you have to spend. So the complexity that way, it gives a lot of advantage. So in some sense, making one-off 3D printed object is always advantageous. Where economy of scale is not there. So you better make small batch quantities and use it for making complex objects. Then you have advantage. And earlier, all products, enterprises go through, a systematic innovation methodology. We call it as NPD, that is New Product Development Framework, where they address a need. After need analysis, they ideate, then they screen using some criteria. They go for the detailing of the design. They get the material, the size, the process, everything here in detailing. Then after a design is made, one has to necessarily test it, and that's where you need a prototype. So prototype testing was always a big thing. You need skill to make the prototypes first, and then you have to test it. And if it is failing, again you have to make a prototype. So it used to take a lot of time to make the prototypes, and 3D printer came to be called known as rapid prototyping mission. Rapid prototyping people used to call, and then before you go to launch. And ideas are always, ideas need to be tested. Why ideas needs to be tested? What you see here is a business case. Why ideas has to be tested first? Because at the conceptual stage, the cost is very less. This is the cost. Y-axis is cost. X-axis is time. As the time passes by, concept design, you have hardly spent anything. Then detailing. Then as you tend to make it, lot of cost is involved here. So it's very important to test an idea by making it. So it's always de-risking the business, uh, you know, um, in order to test an idea. Ideas are tested early so that you don't spend more time on it and don't spend a big fortune on it. So you have here a clay model of a cash register. You see puff model, and here you see a cardboard model. Here you have a breadboard, electronic circuit being tested. These are all prototypes. These are all prototypes, and they give feedback. And depending on the feedback, they go back to design and they modify and change. So NPD has a lot of such things. With the advent of computers, of course, we could do everything on computer. Computer animation and even computer testing simulation we could do, and we could check the kinematics by animation on the screen. But when you tell anyone, your boss, your venture fund, the funding agency, you cannot tell them, I've got a computer model and it works fine. Please fund me. They will say, no, no, I want to see it working. So real touch of, touch and feel is very important in order to gain confidence of the venture capitalist or the bosses or the management. And so it's very important to actually make. So making is not solved by these virtual objects. Today, the making, the cycle time, what you call, has greatly reduced. What you see on the top is it used to be a long time. By using 3D printing, the cycle time has reduced, you know, and that is because of uh, it's uh, it's not like skilled labor is required to make a prototype, and it doesn't require any Egyptian fixtures, you know, and it doesn't require a very high skill. Even a semi-skilled person can operate a 3D printer because it is a advanced technology wherein CAD directly takes care of many things. Now, let me become a kind of devil's advocate. 3D printing is not good because it is costly. 3D printing is not good because 3D file is needed. It is a time consuming process. There are few materials available. Need always a post processing. Directly you cannot use it. And 3D printed object only is good for making prototypes. But all these things have changed. They are becoming cheaper, and many file formats are being used directly, and they are becoming faster, and there are 500 plus material available today, and there are automated post-processing processes are available today which are controlled by robots. In fact, for dental implants and all they do, the processing is done by uh, non-human, so there is no contamination in the process, and so post-processing also is getting automated. And today, what we make can not only become a prototype, but a prototype you can sell it as a final product. So such is the capability today, what we have got. Moving forward, so in digital manufacturing, we have soft input data, and we obtain tangible outputs or the physical products. So in the industry 4.0, this forms the physical side of the cyber physical systems. When you say cyber physical systems, the physical side of that would be these 3D printed, either 3D printing or a CNC, or it could be something together. We call it as hybrid, which is being handled by autonomous robots. There is a slide on that also. So it is a doodle getting as a computer entity, and we can do a virtual rendering on screen, and actually you can make it and explore in hand. A physical model, you can take it out and hold in hand and explore. That is the capability of this technology. So if you ask me, 3D printing is in the center. There is a lot to do with other things. 3D printing is not possible. What all required for this to fill the spectrum? You know, it starts with an idea or a design. You know, without an idea or a design, you can do nothing. Then you have to make a 3D entity, content creation. So for that, you need CAD knowledge. You know, so people may want to use Fusion 360 or Windchill, Creo, or CATIA, SolidWorks, any such thing. And CAD also needs a lot of thinking, design for additive manufacturing as an input. You know, so because people have been in a inertia of thinking for 100 years now, they don't know how to make use of 3D printing. You know, goodness of 3D printing. Many times they think of the constraints what are thrown by the so-called, you know, the conventional manufacturing. So DFAM, Design for Additive Manufacturing, is a new body of knowledge, which is an approach to unlearn the making the conventional way and learn a new way to take advantage of this new technology. That's very important. After CAD, you have to export the file, and we call it a pre-processing. Pre-processing is that activity in which we repair the CAD, make it all right to 3D print. So there is something called as water tightness. Today, this concept of water tightness and all is beyond the scope of today's talk, because I want to keep it very generic, not going deep in technicalities. So a lot of pre-processing happens before a file can be printed. Not every file can be printed. You know, it is like, you know, if I have a drawing file, I cannot print it on a Word. You know, a Word you cannot use it for making a 3D CAD. You know, so all such things are there. So you need to export it properly, and you have to pre-process it. We call it a file fixing and all. Then 3D printing itself, you can see there are two arrows coming. 3D printers need a lot of care, so maintenance they require. They need a lot of love. You know, if you don't treat them well, they will give you a big heart. They will not work for you. And materials are very important, because real world need real materials. You know, so there are a lot of material, and material also pose limitation on the technology what you have to adapt. So 3D printing, as you can see, is a different set of technologies. You know, array of technologies, SLA, SLS. You know, within that red ring, what you have, 3D printing, it is actually different technologies. Some materials are liquid, some are powder, some are solid. You know, all of that. I can say in metal printing, we can say even gas, because the powder metal is actually atomized, and it is fed through inert gases. It's almost like plasma. You know, even such materials are used. You know. And then comes post-processing. What is post-processing? As I said, 3D printing has its own characteristic lines, scales, what we call. And of course, with the new technologies and precision, they become finer and finer. But still, all 3D printed objects need some kind of a post-processing. And that's another area. Then comes the application. So application is the whole world by itself, you know, to conquer. So in some sense, you know, idea generation and creation is very important. So there you can see a career in designing, and reverse engineering, and medical image will come under the top arrow what you see above the CAD. CAD itself is another career, knowing CAD and becoming expert. DFM is yet another career, because you need to be an expert how to utilize by having this new technology, how to work, how it works for the industry, how to unlearn the old way of doing, how to learn the new way of doing. You know, then export and pre-process itself is another big area. Uh, there are a lot of softwares here. We use slicers, we have file fixing software, and so many things here which one has to learn into. And of course 3D printing, how to control it, how to automate it, how to load, how to unload it, how to care it, all this, how to build a new one. All of them has their own this thing. Post processing, of course, you have various technologies like you have polishing, filing, sanding, coloring, plating, and it goes on, big list. Now, all of them, they go into world of application. So application, one can become just an application of 3D printing technology. It's a world by itself. So moving forward, you can see the scope. Today, what we are learning as 3D printing, which is born some 30 years ago, you know, is going to become like a screwdriver one day. Like any other techno, it becomes a mature technology. So today we don't talk of a watch. Watch is still it is there, but watch nobody learns how it is working, how to make a watch. It is accepted now. Like a screwdriver, who learns about a screwdriver? We don't even learn about lathe now. This it is understood. It is there. But same way, 3D printing will become one day very generic. Okay, so we don't study much on the hardware itself, but the software side, lot of scope is there, and on the material side, there a lot of scope is there. So in future, the careers, in software for 3D printing and allied things will be a great scope. And on the other side, materials scientists, material processing industry, there is going to be a huge scope. And moving forward in medical, you can see there are huge application. In fact, we can classify them into 5 groups. At level 0, where there is no risk, one can help to make devices. Okay. And at the second level, where we make anatomical models of any size, shape, and color. And at the third level, you have guides and fixtures. At fourth level, you have implants, and which are going to be inside the body. So as they move on, the risk level, the responsibility is more on the part of the technology, what it can deliver, how it is made. And at the end, you have people are trying out becoming God himself. That is making the building blocks of humans or animals, making skin, making a ear, making a kidney and all. Today, many people walk into Imaginarium and ask, can we get a kidney? I said, why? You want a kidney? You don't have one? No, no, just like that. No, we learned in YouTube, somebody's, Professor Atala is printing kidneys. So we tell them, no, no, it is all kind of lab research work going on. Nothing is ready till now. So the God is playing hide and seek here. Though we can grow tissue on a petri dish by the culture, cell culture, what we call tissue culture, it is very difficult to vascularize these, and that's where we are a long way to go there. People even think of making meat, print meat directly. Don't kill animals. Directly print meat. That's going to be one of the application. The other one is, can you make an organ and test the drugs on it? Don't kill animals and inject guinea pigs, but you make a artificial organ, testing drug efficacy on the thing. That opens up a new area. Before all this, ultimately you get a object which can go into the body. Body will accept it. Kind of thing. Moving forward, a lot of people have been doing. We have been empowering a lot of startups Here is a Bempu from Bangalore, which made this device called hyperthermia monitoring device. And these are all 3D printed, 3D print enabled development. Today, they are very happy working on it. They have produced millions of pieces now through regular conventional route, thanks to the prototype being accepted by the funding agency UNESCO. And now they're happy. And more than anything, it has a societal impact. They're able to save a lot of children in the rural areas. What is the value of technology if it cannot save lives? It is very important for a technology to deliver that promise, to improve quality of life, save lives is very important. Moving forward, I see
We could
the 3D printing will merge with the CNC and robotics to make a hybrid manufacturing system. It is going to be the uh, trinity of manufacturing in future. I think, I think this is the last one. So thanks a lot, guys. I think all of you had a kind of a overview of the technology. I did not go too deep into it. So I want to sign off with this slide of the thing. Then I'll take questions from all of you. I'm sure you'll have a lot of questions. You have small icons here. They stand for various verticals. We are into precious, where we make gold ornaments and all. One off or many off. We make aerospace, automotive parts in under rapid. Life, we make surgical guides, surgical implants and all under life. So, your medical devices under life. Then you have solutions where we sell hardware, software. We can also take turnkey projects. Academy, right now we can see Academy is in action, and Academy is there to help adoption. We go to corporates, we conduct programs for them. From the top managers to the technician, we can train people. And we also have a venture fund, Imagine Ventures, which supports startups, with a corpus fund in the allied field. We mentor them, and we want to pick up and encourage bright young minds. That's the thing. Over to you, Saif. If there is any
Yes,
questions, I would like to.
we have a few Q&As. Can you hear me?
Please. Yeah, I can hear you.
Okay, awesome. So I'm just going to go with the questions one by one, and maybe you can answer them.
Yeah.
So Shayan asks that 3D printing was supposed to make supply chain digital. We have not yet seen that change with scale. Can you share your thoughts on what are the challenges?
Well, yeah, that's true. There are a lot of things said about 3D printing that is not happening, and that's why you don't see it. The technologies earlier, they were not fast enough. Okay, they were not giving material which are for the real world applications. They were still 3D printing materials. So today, I think processes like multi-jet fusion, they are the answers. They make products which are as robust or even better than conventional injection molded part. Okay, and they give accuracies and they give volume. This is going to happen in everything. I think more than anything, the real world has a lot of metals. Today, 3D metal printing is prohibitively costly. Suppose you take this ring. If I were to buy this ring, it may cost about 6,000 rupees. Suppose same thing, I 3D print it, I have to shell out something like 60,000 rupees. It is damn crazy, isn't it? So the technology cost was a great issue. Material was a great issue. But I think as any technology, in smartphone, what they cross, from a small little, Android to a smartphone, the transformation was a revolution. Okay, in 3D printing, there is no revolution. It is a kind of evolution, which is happening very, very gradually. And I think that's where we are stuck. Today, I am very optimistic. In days to come, in a matter of 5 years, lot of metal 3D printers will be flooding the market. Okay, and a lot of patents are getting expired, and the technology becomes open source. And open source means it is open for everyone to think and reflect. And I think that's where the technology will sprint. And we are going to have whatever prophecies we have in supply chain is going to happen. You're going to have a local load center based factories, which will just about do anything and everything. And there's no need for big roads are not required. You know, there is no need for long containers going from one place to the other. A small drone will now supply. So the supply chain is going to be disrupted. Logistics is going to be disrupted because you're going to have in load center, for example, in a small village, you can do anything in a small village. It will be a smart village, I know, and it doesn't require anything more. You have a cradle to cradle, it's like what you call a circular, economy. So all these things will come, and 3D printing is going to be part of. We don't call it a 3D printing. People will forget calling it a 3D printing. That is a new way of making things. Yes. Have I answered you?
Yes, sir. Thank you. Okay, so we have Imtiaz and Nawaz who ask, what are the materials that we can explore for 3D printing, and what are the limitations of each of these materials and their costs?
Well, materials, it is only increasing. As I told you in 1986, when Chakal brought it, he had just only one material. That was photopolymer. Photopolymer, just one. Today, in FDM, when they brought statuses, they had just one material. I remember way back in 2000, I was in my alma mater, IISc Bangalore. I used to run a FDM, and it was ABS, only one material. But today we have 500 different materials. We have metal fill, wood fill, and so many new materials available in filaments. We have powders, we have nylon, we have biocompatibles, we have biodegradables, PLA, PLA and all the biodegradable materials. And you have biomaterials, hydrogels, bio-inks, for example, and you have titanium, you have tantalum, we have different types of steels, tool steel, mortgaging steel, and you have various forms of inconel, you have aluminum. So there are a lot of exotic material available today. Even for that matter, you have gold. You have gold also available. You have silver available. We have alloys of them, and you have things like uh, shape memory alloys. Shape memory material is available. So I think today, you know, people are exploring very small micro materials called MEMS that are used as soil. So they are used for biobots because they make a small robot which is swallowed inside, as a pill that goes and delivers the drug. Such small things are also being done, in using 3D printing. So 3D printing is highly capable, but when you see building a house, building an apartment, building a large bridge, they all require a large machine. It's like a moving equipment only. They have to move, they have to be anchored, and they have to build. And I think there was a concept in IISc under Astra where they used to dig foundation, soil, and using that soil they used to make brick, and they used to build the houses. Same way they say 3D printers will be deployed in moon, and using moon soil, moon rocks, they build a colony over there. Same thing they're thinking in the Mars also. If we go to Mars and we create our own habitat, we'll have our own atmosphere created and all. So people are thinking in many creative ways. It's very important to dream. Without dream, nothing happens. You know, so I wish all of you dream, dream boldly, and what is today a dream, tomorrow it becomes reality. Okay. And today, you know, I'm able to reach all of you. You're sitting in various places, thanks to the technology. You know, it's a possible, and the COVID has helped. It has acted as a kind of a catalyst, you know, to reach out all of you today. You know, I'm sure many of you will pursue this technology. Many of you can become inventors. I don't know. Today, what I am preaching you, tomorrow I will learn from you guys.
Thank you so much. So I think that was a very, very inspiring thing. Actually, wanted to continue on that on the inventing part. We have a few questions who say that you know who can if you wanted to pursue 3D printing as a career, do you need to have an architectural background, or you know how do you go about something like this?
Well, as you see the spectrum here, a lot of, I'll take you to the spectrum. You can see here, can they all see the screen?
Yeah.
So you can see here, uh, eh, I was giving a challenge to schools and high schools, actually. I'll give a 3D printer to you freely if you tell me what are you going to do with it for on 365 days of a year. But you should tell me now. People started writing what they will do, and they could not make even 10 in the list. You know, that means it's very important application where you are going to apply, and application comes from a need. See, idea and design is very important. If you don't mind it, it doesn't matter. So you have to mind it first. So it is very important. So lot of designers, you know, designers who are going to use this as a technology. So designers need to be there, you know, in order to cater to 3D printing. So 3D printing as a hardware, you know, can also be assembled and pursued is another thing. But we need a lot of CAD also. The designers think only, while CAD people or the CAD operators who create content of a 3D. Without a 3D content, you can do nothing actually. You know, nobody will give you a CAD. Okay, chalo, you want this, you take it. You know, they will not. Of course, there are something in internet available, but if you want your own things, you need to create. So you have to learn. So what I can say is, it all depends on where you are in what application area you are. You're in post processing. You can have a diploma, you can have a ITI, you know, or you have a seventh pass, you know, some training, because it is the same thing. It is about sanding, it is about polishing, it is about buffing, you know, the conventional way of finishing. So these boys and girls will be trained here. They don't require any great, only training is important. Whereas if you take CAD, you need to have CAD knowledge. You know, to know mathematics, you need to know engineering, little bit of things. If you're a jewelry designer, you need to know aesthetic sensibilities, you know, understanding. So here, when you say design and idea, it may come from an engineer, it may come from a doctor, it may come from a jewelry designer, it can come from an architect. You know, idea can come from anyone, but ultimately the converters are the CAD operators. Okay, so in the whole value chain, what you see here, there are various opportunities. So people can become coders for 3D printers. They can build 3D printers. So they need mechatronics, electronics background, mechanical background. No, such people will have a lot of things. On materials, you need to have material science background or chemistry background, industrial chemistry background. They will pursue the material synthesis and all. Care is more to do with the people who are into maintenance. So they need to be strong in electronics and mechatronics, you know. And in fact, the people who care are the people who are the creators also of machine hardware. They know the process so well, they can not only repair, but they are the creators of the new technology also, because they toy with the hardware what they have. And physics and chemistry of things. There is a lot of physics in 3D printer. Laser and all is pure, optics, which are physics. But material is pure chemistry, and of course the other things which work on mechanical. So it's a kind of multifaceted, multidisciplinary area where each one, if they pursue, no matter who you are, if you are a doctor, you can utilize it. If you're an architect, you can utilize it. If you're a civil engineer, you can utilize it. If you're an electrical engineer, you can utilize it. You're a product designer, maximum you can utilize the technology. And it's enabler, it's an enabler, not only. So as a career, there are a world of opportunity, even application you take. People who can apply in jewelry are there. People who apply in industry, aerospace are there. In aerospace, the payload is so important. Payload means you need to make it lightweight. Lightweight structures have a different approach where we have topology optimization. We have Voronoi structures, and we have so many things, which are part of creation, which mimics nature. So in application area, you have a huge scope here. Sky is not the limit, actually. We have gone to moon, we have gone to Mars also. And then we have to go beyond the solar system into deep space. Such is the opportunity what you have in the world of applications. People are thinking of even printing electronic circuits, printing food, printing chocolates, printing accessories, printing cloth, and printing organs. So you see, it's a huge area of application area is huge. It is not even limited by your imagination. It's beyond that, and we have to train ourselves in order to do that. Here, the beginning of the spectrum, you have idea and design. Thinking is very important. Without any bias, you should add, connect dots, and see the world in a new order. How today this has become a new normal. 3D printing will become a new normal, and people will forget it is 3D printing, because it is, after all, another way of making things. Why to give it a special status? It is just making things. Today, as a customer, who is bothered about whether something is 3D printed or not? Consumption is, who cares whether something is 3D printed or not? Because it is another way of making things. But because it creates value, it's important. Hope I have answered your question.
Yes, sir. Thank you. So we have a few more questions before we wrap up.
Please.
Okay. So we have a person who asks, can a number of materials be combined to be printed together, like aluminum, glass windows, brick walls? Can you combine a few materials to print something together?
Well, yes, people have tried. Metal, bimetal printing I have seen, and also plastics, different colored plastic they mix. That is there. We have composites, nylon and glass. They are getting 30% glass filled nylon, which is a composite material. Like they combine the beauty of two things. ABS is a composite plastic. It has got A, B, and S. Acrylonitrile, butadiene, and styrene. ABS. Though it is a composite now, which is available as ABS single material, though it is a composite by itself. So it is possible to mix, but when you have liquid to liquid, we can mix. Solid to solid, we can mix. Powder to powder, we can mix. But in between, we cannot mix things. That is going to be a limitation, and well, I think it is going to change. And beauty is, because we are able to control material flow, at a pixel level, which is not possible it is only possible by nature. If humans, in their constant endeavor to, imitate nature and create nature like things, he's taking this step wherein we have a control over a pixel, small micro uh, volume, uh, pixel becomes a voxel in 3D printing. It's a volume. What you call as pixel in 2D becomes a voxel in 3D. Okay. So it is possible now to control the voxel level property of material. That means what? I can have a conductor, I can have a semiconductor, I can have a insulator. Okay. I can have a physical thing which is then a bio, thing. In between, I can have an inhibitor also. So I can have drugs, for example, layer by layer. I can have drugs. I can print drug for a individual's body mass index. Supposing you have 500 mg, you can cut it and you can only get 200 mg. But today, by 3D printing a custom thing, it will take your body mass index and will only make you 158 grams. That will it will make and give. So this is the beauty, the capability of new technologies. You're able to dispense what is required on demand, and that brings in a lot of things. Now, if you take a sandwich, because 3D printing is like a layer by layer, I can have sandwich. If you take the example of sandwich today, sandwich, I have two bread pieces. If I put, cucumber, it becomes a cucumber sandwich. If I put chutney, it becomes a chutney sandwich. If I put a jam, it becomes a jam sandwich. If you want to put any other material, you can keep on making it. So you can actually play with the material because you have a layer by layer control. Not only layer by layer, you have a voxel control, and that brings in a concept of digital material. Digital material means you have the capability to engineer, something like a few months, for example. We have inside our body, we have a scaffold, structure, hati hai, the bones, which are like rock, and outside you have so many vascularization, blood flowing with, veins and all, capillaries and all. Then your muscle, which is soft. At the same time, it's like a spring. Then you have outer skin. All these are able to be produced. In 9 months in mother's womb. You come with a bio cameras, your eyes. You come ready with a bio headphones and microphone. You come with a CPU. And all that. And the beauty is, the human beings are actually mimicking it in some sense. Today, it is possible to print hard and soft together. It is possible to print opaque and transparent together, in one go. Just like how our hand is, it has got a bone and it has a soft exoskeleton. Such capabilities that 3D printing offers. Technology, once it is figured out, we can then work on it to make it faster in better quality.
Yeah.
I think need of the hour is making it affordable, very important. Technology, which is a niche market, a niche application and all, will not go and reach the grassroots. It has to be uh, viable, affordable by all. And I'm sure all these technologies which are there today, patented, patent is given only 20 years. The patents will expire, and many of them are expired. And once they expire, a lot of open source people will put their own new thoughts, and that is a human intent. There is always scope to improve things, no matter what it is. No matter what it is, can keep on improving it. And I think that will is going to fuel future growth in this sector.
Right.
Yes.
So thank you so much. I think we'll take one last question before we wrap up.
Please.
So we have Armand Villani who asks that you said that 3D printed articles will be used as an end product. what are the methods or softwares that we could use for structural analysis of these materials that are 3D printed, these plastics and metals that are 3D printed? How can we structurally analyze them?
Same way as you do for others. For example, you have a steel. How do you test steel? You do the same way because application is same. You know, who worries about whether it's 3D printed or it is as long as it has to do the service of the real world application, it has to fulfill that. Suppose you have a steel, what you do is you go to a UTM and you test the steel. You pull it and you pull it till it breaks, and you have the ultimate strength recorded. Same way, a 3D printed object, I cannot use it softly because it is 3D printed. It has to be used the same way as the real world anything. So it has to be subjected to the same test, analysis by the same test. What you have, there is no difference.
Right. Right. Okay. So I think we'll wrap up with one last question. I think we have a lot of people who are asking, what sort of 3D printers would you suggest for non-commercial purposes? Suggest for buying to sort of experiment with. What do you think somebody who wants to just do it as a hobby should go into?
I think there are a lot of FDM, that is filament based, 3D printers available. You can try, first start with a 3D doodler, which is only 1,000 rupees, investment of 1,000 rupees, and buy a kit, and it is lot nice to build your own 3D printer. And I'm sure it is possible, and I remember for demonstrating one of the 3D printers in the Maker Asylum long time ago when they were in Bandra. A lot of people came and saw it there. Now all of them have become experts and they're making their own 3D printers. Many have become companies. And one was my colleague also in Imaginary. He went to Germany to study further. And he was there in that demonstration, which I gave long time ago. So a lot of kits are available. They're about 7,000, 8,000, 10,000 rupees. And they're called Pursa kits. There is a Make Mendel. There are a lot of brands. You can Google, you'll find all of them. They're available in India. There are a lot of Indian companies making them. And I think you can build. Joy of building is very important. By building, also how to repair. Once you build anything, for the first time, what you build, you'll never work. And there is a community. You post it to community, or come to Imaginarium, will help you. Or we can connect to our email. So once you teach others in the community. It's like a contagious. So one will teach others. Peers will peer learning. Is very very satisfying and joyful learning. And people can. I'm sure there are a lot of advanced users who can also help you. And today, world has become one because of network communication. You can get anything answered on Google, for example, and you have a lot of queries. So one can become expert, in no time. Passion is what is important, and it doesn't really require a technical background. Also, the passion drives. Yeah.
Okay, thank you so much.
Most welcome.
Thank you so much, Doctor. We had a brilliant, absolutely great time with you. I think you covered most of it very well. In fact, I love the part where you said, "Who are we? We are clients, and when do we want it? We want it now." I think that you made it a very wholesome session, and I think I speak on all of the attendees' behalf when I say that we absolutely loved it. To the attendees, thank you for participating today. I'm sure we can keep connected. In fact, I am posting out a link to the WhatsApp group of Career Spark, where you can stay connected with us for any future webinars that you might want to do with us. And thank you again, Mr. Rao, for
Thank you.
having,
Thank you.
yeah,
Thank you.
for this
Well,
wonderful
it was
webinar.
really very my pleasure, and thanks for the opportunity. Aga Khan
Education.
Development
Yeah.
Education Network. Thank you.
Thank you so much, sir.
Thank you.
We'll stay in touch, sir.
Sure.